Hello everyone, welcome to Amazon Web Services Machine Learning Operations with AWS, and this is day 4. So in the previous 3 days we have discussed about many different services of AWS, starting with account creation, then AWS budgets, identity and access management, then regarding virtual machines, EC2, how to create it, how to deploy a sample Apache HTTPD server, and then we have used auto scaling, load balancing, and how to achieve it. We have tried and used it. Finally, we have discussed about elastic beanstalk, right? So after that we are just going to continue with the next topic. So next we are going to see something which is known as AWS Lambda. So what is this AWS Lambda? So they used to advertise this AWS Lambda as a serverless compute service. So what is this serverless? Have you imagined, you would have heard about serverless in many places. Have you wondered what is meant by serverless? So for example, if you are having an application, if you wanted to deploy and if you wanted to run, so you need something known as server, whether it can be a physical server or something like a virtual machine which you rent. So it also has a physical server, but in the AWS or the cloud service providers data center, right? So there should be some physical entity which is storing it. So, but this serverless is defining like something like there is no server at all. So how can we like do without server? So the meaning of this serverless is not something like no server. So this serverless means the cloud provider allocates machine resources on demand and taking care of the server on your behalf. Okay, so they will take care of it. Okay, you don't have to worry about the server. All the server related things will be taken care of by them. Okay, so that's what called as serverless. Okay, so the word serverless means it is not like there is no server at all. The word serverless means you don't have to worry about it. The cloud service provider will take care of the server. So that's what the meaning of serverless is. So then coming into this AWS Lambda, so as I told you earlier, this AWS Lambda is a serverless compute service that runs whatever code you require, that runs your code in response to a trigger and automatically manages the underlying compute resources for you. So this you can use it for some automation tasks, and these trigger may include such as an update or something like a trigger happens. Okay, if you are having a website, you can set it like if they go to some other, like for example, if they add an item in a shopping cart, what you have to do, you may have to do some process like you have to like show them the price, or you can send them some query email and something like that. This should be done automatically and you can use this Lambda for it. So one common example of AWS Lambda is, for example, we are having something known as S3 in Amazon. So this S3 we are going to see about it in this session. So this S3 is simple storage service. It is for storing. Okay, we are going to see about it, don't worry about it. So this storage, okay, for example, if you are taking a photo and if you are uploading it to this S3, you can actually make this as a trigger. Okay, whenever a photo is uploaded in this S3, that will trigger this Lambda. Okay, you can set it. So this will give you a trigger to the Lambda, and this Lambda, what it will do, it will perform the code you have here. So this code, if I have a code something like whatever the photo I am uploading to S3, it should be automatically resized to some format. Okay, it should resize and it should be stored back into that S3. You can do it with the AWS Lambda. Here you will be having some code like for Python code, you can use it to open CV, or something like CV2, you can reshape it and so on. Okay, or pill, you can use it. So once you done it, you can actually redirect back it to S3 to store it. Okay, so that's what the idea behind this AWS Lambda example. Is it clear till now? So I think we can go and see a hands-on with AWS Lambda. So how it's working. I can go and search something like Lambda in AWS. Run code without thinking about servers. So that's what they advertise in Lambda. And once again, please remember, something known as serverless means it is not like there is no server at all. It is something like you don't have to worry about the server. So they will take care of it. Okay, this is the dashboard. And something known as you have to create a function to actually create a Lambda, and you can author it from scratch. Okay, so I'll create a name, my Lambda function, okay, and the runtime you can choose whatever the code you are going to perform. So I'll just go with Node.js. If you want, you can choose other languages too, okay, it's also supported on these languages. I'll just go with this one. I want the 86 architecture, fine, we can go and create the function. So it will take few seconds to actually create it. So once it's done, we'll try to explore it. Okay, we have successfully created the function, and what you can do is you can test it. For example, here you can add a trigger, like you can select a source, and there are many sources, so whatever like changes happen, you can actually have it as a trigger. And I can go and select this S3, and you have to give what is the storage where it is. So it's like if something added to this storage, you can do that task and something like that. And this will go into the function where you can have multiple layers and work on it, okay, through your code. This is the code, you can find it below this page, okay, this screen. If you come below, you can find this is the code where exactly this Lambda is going to perform, okay. And this is like you can add a destination. So for example, if you have a photo, if you upload it, it should be perform this task and come out and store it here automatically. So that's what the idea behind it. So we are not going to use any trigger just now, so we'll just try to work with this code, and you can test it actually here whether it is working or not. So what I'm going to do is, if you want to test it, you have to have something known as configure test event. You can go and click it, and you can create a new event. So my test check, okay, so you can check it. And this is the JSON format. You can go and rename it actually. So like this is a like standard one. I just want to check whether it is working or not. So I'll just give something like this one. So I'll give something like products, and I have a value which is TV. Okay, this is our answer. We have it in the products. Okay, I'll just save it. So I'll try to use it. If you don't know about this, you don't have to worry about it. This is for just a representation. Lambda, how it's working, how to use it. So I'll just go and get a constant, okay, product equal to. So you can go and get this from this event, because there this test event is there. We have our product TV answer is there. So you can go and get event dot products, okay, and I can pass this product constant here also in the body of this JSON. I can go and give like hello, we don't want it, the information we have, information product, okay. So I'll just close this, plus I want this product which we are getting from that event. So I'll pass the product variable here, okay. And now that's it. Once you've done any changes here, you can go and deploy it, okay. This is the file where you can have your code, okay. If you are performing some other task, you can have it here in the environment, and you can deploy it, which means whatever the changes you've done, now it's get updated. And if you want to check whether it is running or not, you can go and test it now. So it will be run based on the test configuration which I have created earlier. I can go and click this test, and it will execute, and we got our response here. See here, it is giving me the information product, and the answer is TV, and it is deployed correctly. So this is how you can verify simply without going any high complex like that image task, okay. If you want to test it, you can perform the same and verify how to use Lambda. And once it is working, you can go and test it, like we have seen the test event, right? You can create other test event also. You can monitor it whether it is successfully ran or not. Okay, it will take some time to get updated. So this will give you whether it is working. So there is no that much data, we have just ran it once, okay. So if you have, like for example, if you add a trigger like S3, whenever an image uploaded, it will perform some task, and if it goes, like it will automatically keep on doing, and you can find this cloud metrics where how much is done, what is the error rate, what is the success rate, and you can find it here. And regarding the configuration about it and the versions, you can get it here. Okay, that's what about this AWS Lambda function. So actually, like some of these tasks topics we are not going to use for this machine learning operation, so I'll just give a basic intro about it, not that much in depth because it's not our requirement here. And some topics like storage and all, we need to have a very good knowledge for our machine learning operations. So we are going to see elaborately in today's class about storage also. Okay, so once we are completed, if you don't want to use this, we can just actually go and delete it. Okay, once you are done, so how to do it? You can go and check for functions, you can go and click the dashboard, you can go and click the functions, and here you can find it. I'll just go and click the actions to delete it. I can give delete. So now this thing is deleted, and okay, fine. So once you are done, if you are practicing, it's good to delete once you completed it entirely. Clear? So next we'll go and see something known as what is containers, what is microservice, what is container orchestration, and we are going to see these topics. So we are not going to go into hands-on with these topics because it's not required for this course, but I just want to enlighten you with these topics. Okay, we'll just see what is, and you want to have this basic intro about it like we had in PPC. Okay. You can convert this masterclass into 1 month certified internship on machine learning operations with AWS. Once you join the internship, you will be getting all these benefits such as 30 days of live sessions, 90 days of access to all the records, 6+ source codes of AWS projects, downloadable code files, 30 days downloadable PPTs, 5 mentor live and mastermind session in Zoom where you can directly interact with the mentor and clarify all your doubts, internship confirmation letter, and then internship certification when you join this internship. To avail this internship, you can get it at a discounted fee at $799. The registration link is posted in chat box. You can get benefited by getting all these benefits of internship by joining the internship at this registration link. It is available at this discounted fee at $799. So once you join as an internship user, it is a 1 month internship. So you'll be getting a separate agenda and separate contents for 30 days, which includes basics of AWS, in-depth machine learning with deep learning as well as machine learning operations with from the scratch with GitHub, and then Sagemaker deployments and AWS AI services. We'll be deploying the projects. We have projects such as vehicle insurance claim fraud detection, Avalon age prediction, Sagemaker project, clustering project, census income prediction project with deployment, as well as music rating recommender system project with deployment. So we'll be creating pipeline in AWS, and we can deploy the model and give it to the client in production. With that API link, you can get predictions real time. So you can get all these benefits at this discounted fee at $799, and the registration link is posted in chat box. So continuing with it, the containers. So what is a container? So container are lightweight and isolated unit of software packaging that includes everything needed to run an application like code, runtime, server tool, and library. And the container provide a consistent and predictable environment for software to run regardless of underlying infrastructure. So it may be a little bit confusing, but I'll give you a simple example with that you can understand it easily. Okay. For example, in earlier days, what will happen is the software developer will create a software or an application which will be working very perfectly in his own environment or his own system. So he has completed it successfully. Now he is pushing or giving it to the client. And when they try to use it, it is not running in their system, and they are telling nothing is working and it's full of error. What is happening here? And they are asking it. But you are telling, like, you are the developer and you are telling it works completely fine in my system. It had worked very properly. So what is the thing is, your system may have some kind of infrastructure and some specifications, some OS, some type of architecture you will be having, right? But you may not expect all the one, like everyone will have the same, and in such case it may not work properly. Okay, it may work in your system because it is compatible with it, but it may not compatible with their system. So what you can do is, they try to avoid this, and what they have done is they have created something known as container. And this container or a lightweight and isolated unit of software package. So it's like packaging. So if you are going to use Python, okay, for example, you are creating a Python application, what you will be doing is you will take, okay, you will install like what is the like OS you are going to run. For example, I'll just mention Linux or Windows, whatever it is. And then what are the like libraries? You can go and use pip to automatically install all the, create an environment, run all the libraries. Like if you are going to use Pandas, you want to install Pandas. If you want Numpy, you can install Numpy with it automatically. So once you install all these things and everything is ready, if you go and run your code, like a machine learning code, it will run very smoothly, right? So there is no issue because everything required is already there. So this is how you will package in a container, okay? And the containers provide a consistent and predictable environment for software to run regardless of the infrastructure which anyone uses. And there is a difference between a container and a virtual machine also. There are some advantage with the containers too. For example, in virtual machine, as we know earlier, this infrastructure, we would have used hypervisor and created partitions, right? And this partitions, like it is going to create many partitions where this person will have one part of it, this person have another part, and this person have another part. So here what a major disadvantage is, so this person may have some empty space, like for example some space or some configuration which will be like sleeping and no work for it. But when you come here for this participant, okay, he has like, he needs something else, okay, he need extra but he is not having. So this kind of wastage is happening in virtual machine. But when you go for container, in that infrastructure they will have their own operating system, and above that there is something known as container engine, where you can have different container where they can install their builds and library and they can run with that too. And there are some advantages, like this shared environment is going to give you a lot of advantages, okay? So that's what the idea behind this container is. And the top container tool, if you have heard about it, like Docker is a like very famous this for creating this container and manage it, okay? So next one is something known as microservice. So what is known as microservices? Do you have any idea about what is a microservices if you have heard about it earlier? So the thing is, microservice refer to a software architecture, okay? And what is the architecture pattern is, where an application is built as a collection of small and independent services. So instead of having a single application, we are going to split them into parts, and this is called as microservice. And these small parts can run individually, okay? They have their role, and they will run individually, and collectively they can do the work of an application. So entirely they will be doing one process, but they have their individual role. Since a microservice architecture consists of units that run independently, each service can be deployed, updated, or it can be developed, updated, or deployed and scaled without affecting the other. So if you are having multiple units, if you want to work on one unit, you don't want to stop the entire thing, where you can take and work on one unit and attach with it exactly. So that's how this thing happens. So it is called as monolithic with this microservice. So if you have it entirely, okay, for example, if you have a e-commerce application, so it would have a single large code base where all the functionalities such as product management or order processing or user authentication and payment processing, or like they'll have or come under this monolithic, where one thing will be responsible for everything inside of it. But when you go for microservice, okay, where you can split the role, for example, you will be having a microservice for product service, one for user service, one for payment, one for order service. You will be having different things. They have to do their role. They have to do their role separately, but collectively they will be doing that online application entirely successful. So that's what this difference between monolithic and microservices is. And have you till now, do you ever imagine how this microservice they are going to achieve it? So this can be achieved with the help of containers. For example, so one microservice will be in one container, another microservice will be in another container. So you can pack them into different containers and you can make them run coordinately to achieve the application. Okay, each container represents a self-contained unit that provide the necessary isolation and portability to deploy and manage microservices effectively. And now, as you see earlier, so we have many microservices like this in different containers. So how are you going to make it run properly? They want to run together, right? And then only it can run successful. So how are you going to achieve it? So to achieve this, we are going to use something known as container orchestration. So if you have heard about this term, something known as container orchestration, which is nothing but we are going to orchestrate the containers. We'll be having different containers, it is microservices. So if you want to make them run together, you can use this container orchestration, which refers to the management and coordination of containerized application across a cluster of machines on a distributed infrastructure. So this automates the deployment, management, scaling and network of containers. And the top or famous orchestration tool is known as Kubernetes. You would have heard about it. It's a separate application where you can use it for like container orchestration. And in Amazon Web Services, we are having Elastic Container Service for the role of Kubernetes. You can also have, this is like for packing, managing the containers across a cluster of EC2 instances. And you can also have something known as Elastic Kubernetes Service. So this is a Kubernetes application but tailored fit for Amazon Web Services. So we'll have all the, like, you can take advantage of all the additional AWS services. Along with that, you can work with Kubernetes itself. So that's what this AKS is. So this also plays the same role. And once again, I'll just give a recap of what is a container, where you can store, package entire application along with the necessary things. And instead of monolithic, you can go for microservice, where each will be different parts and they'll work together to achieve the application. And something known as container orchestration is there to achieve this microservice through containers. If it want to run together, you can go for this orchestration tools like Kubernetes. So when you go for AWS, we are not going to see hands-on. I'll just show you where it is available and something like that. So you can go and search something like Elastic. So instead of container service, we'll just go and see first container registry. So this we haven't seen till now. So this is something like a repository where you can store whatever things you have for this Docker container. Okay, you can store files here. So this is like a repository and you can create it here. And if you want to do the orchestration, you can go with Elastic Container Service. Okay, so this is like a way to run the containers. So where we'll be creating something known as clusters. You can create a clusters and run them, make them run, and inside of it you can store them and make them run coordinately. And we also have Elastic Kubernetes Service. So it's Kubernetes, but you can use it through AWS, and there are some features based on EKS and AWS. You can have both. Okay, this is what the EKS is. So we are not going to use this in this course, so we are just going to skip it. And then we are going to start with data storage in AWS. So this is very important. We want to see how to store the data, because data is important for us in machine learning and machine learning operations. So we are going to see how to handle and store the data in AWS. Starting with the types of storage. So what are the types of storages available? So if the file is if the thing is stored in a block, it is called as block storage. If it is stored as a file, it is known as file storage. If it is stored as an object, it is called as object storage. Okay, and you can see what is a interface you can use it. So this block storage needs operating system, this file storage need user system, and this object can be program or API. And the cost, this will be high, this will be middle, and this will be very low. And you can see the performance. This is just an image, how this is very fast, and this is the difference we can see from the image itself. And what is the scale? You can see it like what is the use case. When you go for block storage, you are using it for storing OS and database, something like that. When you go for file storage, you will be like sharing user data, web content, something like that. If you want like store images, PDFs, videos, you can go with object storage. Okay. And for block storage in AWS, we have Amazon EBS, which is known as Amazon Elastic Block Store. And if you remember about EC2, you would have known about Elastic Block Store, because when we discuss about EC2, we have choose the 8 GB of elastic block store, okay, for our OS to run. So it makes sense now, right? So block store is for running OS, so it is a dedicated thing, okay. And elastic block store, we have 30 GB of free tier, so we have used 8 GB for that Linux environment, right? So that's what that elastic block store is. So it's a block storage. And when you go for file storage, you can store it using Amazon Elastic File System. And when you go for object storage in AWS, we can use Amazon S3, which is used to store object storage for files and something like that. Okay, you can see it here for images, PDFs, videos, all the files, Excel files. You can store it there in Amazon S3. We'll be going hands-on with S3 because it's very important for us in machine learning things. So before starting with these things, you want to just have an idea what is the terminology related with data storage. For example, you want to have an idea about what is availability, what is durability, what is consistency, and what is scaling. So we'll start with availability first. What is availability? So these things, okay, you are going to store your entire database or data in this Amazon Web Services, and it should be like reliable, which means you want to believe whether it is like, it should be proper, right? But these things may have some period where it may not available. Okay, these are machines and sometimes they may go like out of it. For example, sometimes the web server, like they may go down, right? So you cannot access it for some time, some issues, then you can get it back. And when you compare the availability based on the percentage, if it is 99%, then the maximum unavailability, which means the time which like they are not available per year, is like 3 days and 15 hours is this 99% availability means. If it is 99.9%, then 8 hours and 45 minutes are lost in a year, which means in this period you cannot actually access it. It may be continuous or like in patch, okay. If it's 99.95%, which means in a year 4 hours and 22 minutes may go down. And if it's 99.99, then 52 minutes will be lost, okay, something like 52 minutes may lost. And if it's 99.999%, then it's 5 minutes will be gone. Okay, this is the maximum availability you can achieve. And these are the application. You want this maximum like unavailability should be very low, and you want this especially in this ATM transactions. Okay, so it's very important, right? You don't want to lose the information. And AWS is assuring we will be getting 99.999%. So how they are achieving, they will be having multiple availability zone, making it proper. And what is durability? So there is something known as 11 nines, okay, totally. 99.99 you will be having totally, it's called as 11 nines. You can search it in internet. They will be mentioning a durability. So if you store 1 million object for 10 million years in this AWS, they are telling you would expect to lose one file in that time. Compare 1 million object for 10 million years. In this 1 million object, you may lose one file in that time, in this entire duration. This is called as 11 nines. It's highly durable. And then something known as consistency. So there is something known as consistency, which refers to the state of data being coherent and synchronized across multiple distributed systems or replicas. So how connected it is, whether it is synchronized, whether it is proper. So when data is stored and accessed in a distributed environment, maintaining consistency becomes a critical factor. So we will be deploying, and these data may be stored in multiple availability zone, and they want to be synchronized actually, right? And for example, if you are having a server and your client is doing something, a transaction from India, he have paid, okay, and this data, you are from US, for example, you are sitting in US, you are connected to that AZ or that availability zone. He had done, okay, he done and he connected to that AZ, but it is not updated to you, okay, it's not synchronized. For example, you are having a 5 minutes delay. Will it be correct? There will be lot of issue will go on in this 5 minutes, right? He will tell I paid, but you are telling like I haven't got anything. Where it is lost. Is it lost? No, right? So it should be synchronized. So that's what known as consistency, and it should be highly consistent in many part. So when you consider this consistency, there are two types. So one type is called as strong consistency. So what is the strong consistency is? This simply means the data must be strongly consistent at all the time. Okay, all the server node across the world should be contain the same value. Whatever, like if I do a change at that time, all the place in the world, they should have the same message. Okay, the change should be same at any point in time. And the example is transactional application like money sending and all, they should be strongly consistent. And there is something else which is known as eventual consistency. So in eventual consistency, different copies of the data may not be immediately in sync. Okay, there cannot be any immediate sync, but over the time there should be a little lag, but they will be accompanied. For example, in social media. For example, if you are posting a post in social media, any of the social media, it may take some lag. For example, after 2 minutes, your friend may see your post. So that delay can be acceptable. This consistency is proper, right? In social media, you don't want something like this transactional application. So this may not be an issue. You can have little lag, there is no issue. This is what called as eventual consistency. And there is something known as atomicity. So what is this atomicity? It's related to the transaction in a database or a system that ensures that all the operations within the transaction are treated as a single and indivisible unit. Okay, it should be single, and if I tell you in one word or in single sentence, an atomic transaction is something like all or nothing. Either all should happen or nothing should be changed. Like it guarantees that either all the operation in the transaction are successfully completed and applied to the database, or none of them are applied at all. So like in transactions, you would be performing some transaction, and if in between you haven't completed it, but in between if it stops, then it's nothing. Okay, you don't want to process it. Only when if he completely process it, okay, he done the payment, everything's done, you received the money, then only it should terminate. So that's what known as atomic transaction, where either everything should happen or all should be properly completed or nothing should be happen. Okay, these are the terminologies. And regarding scaling, so for example, you will be having some sort of storage. Okay, there will be some limit, right? And if you want to increase your system size, you can go for something known as vertical scaling and horizontal scaling. What is vertical scaling? So with what is the instance you are having, you can just buy more instance or increase the instance type. Okay, you can have or big storage and something like that. But if you go for horizontal scaling, which means you can connect multiple instances and go with it. Okay, if you have multiple instances, that also should increase, right? So this is what known as vertical scaling, and this is known as horizontal scaling. So now it's time for us to go hands-on. So we are going to see each of them hands-on. So what is the types of data formats available? Okay, we want to learn about the data formats available right now. What is known as structured data? So we'll be having like a table where rows and columns will be there, and it is structured. And this structured data are accessible through relational SQL databases, right? SQL is a language, right, for database management. And when you go for semi-structured data, we'll be having key value pairs. Okay, it's called as NoSQL database. You can use NoSQL languages to access this semi-structured data. It will be in key and value pair. When you go for unstructured data like photos or videos, you can store it in object or block or file storage, guys. We'll kickstart with structured data. If you want to perform the structured data, you can store tables and rows using relational SQL database. Like if you have Amazon RDS, so in Amazon they have this RDS, which is nothing but relational data system database service. Okay, Amazon relational database service is a managed SQL database service provided by AWS. It also helps with relational database management tasks such as data migration, backup, recovery, patching, etc. So when you go for scalability of this RDS, so it allows you to easily adjust compute and storage resources to handle workloads efficiently. And when you go for atomicity, RDS ensures that transactions are treated as indivisible unit, which means either fully committed or nothing comes. Okay, like atomicity. And when you go for durability, RDS automatically replicates data across multiple AZ to ensure your data won't go away. Okay, it may, if you lost in one AZ, you have the backup in other AZ. So like we have discussed about the 11 nines, right? So it can be achieved. And regarding availability, RDS provides highly available through features like multiple availability zone deployments, which replicates data synchronously to standby instances. So they are connected to through high redundancy and low latency, and they want to make it available all the time. So it's time for us to go hands-on. So I'll just go and use this RDS and we'll try to create it, okay, in our console. I'll go and search for RDS, which is, we'll wait for it to load. Yeah, Relational Database Service. This is the dashboard. You can go and click this create database, or where here you can see the database which is available. So nothing right now. So you can create a database. So there are certain things you want to check this correctly, so then only you can use it properly. So we'll go with standard create, and in the engine options you have many compatible versions. So I'm going to use MySQL to use this database. So it's a language, and you can see what all things it's supported. Okay, and in the engine version and the template you can go and select this free tier. So this is enough for just practicing. And in the setting it's database name 1, and our master username is admin. It is important. And you can create a password. So I'll just go and create a password. Okay, and then there is another important thing here. You can go with db.t2.micro. that is enough for the practicing. And in the connectivity, it is very important to make this public access, so then only you can connect, okay, with your, like for example, if you have MySQL workbench, then you can connect it. This should be yes. Okay, and that's it. You can go and select create database. So this is going to take some time, and once it is completed you can actually use it to connect with MySQL database. So we'll wait for it to complete. Okay, now it's complete, but we have to do some tasks here. So one thing you have to check, once you click it, you can go inside of it, and you want to check one thing. You can go into the security group, so it will take you to the EC2 security console, and you can click the security ID, and you want to change one thing, and you want to check if you don't have this inbound rule, you can edit, and please verify whether you have this all traffic, which is custom, and custom from anywhere in this port. Okay, it should be allowed, then only you can use it. So since I haven't made any change, I already have it, but I'll ask you to verify once again whether it is like is there or not. Okay, then only you can do it smoothly, otherwise you'll be getting error in connection. So now it's time for us to connect it to our MySQL workbench. And what I can do is, you can use this endpoint. Okay, so you can copy this, and it's to port 3306. And what you are going to do is, we'll go and search for MySQL workbench. So this is to work with MySQL. You can go, if you have this, you can open it, and we can create a connection to work with MySQL. Okay, you can go and click this plus to create a new connection. In the name of host name, you have to pass this link which we have copied now, and in root we have our name as admin, and here we have to enter our password, and let us give some connection name db1 RDS, something like that. Okay, and this is port 3306. This should run, and we'll go and click test connection. Okay, successfully it is made. And two things, like when you create it, this should be public. Okay, it should be publicly accessible, and you want to verify whether it is available. Like you have to change it to all traffic, and it is available IP from anywhere. So please make sure you have both of this, then only you can make this successful connection. Okay, and if you click OK, this will be like completed. But when you try to open this, okay, it will ask you for password which you want to enter properly, which you have created. Okay, yeah, since we are connected it directly, it's opening. And as you can see here, so we have our query bench here, so we can write SQL commands here. For example, I'll go and use this option. I'll create, see here, this is where our database will be. So this is, we don't have any, so I'll just go and create database. This is just for example I'm showing, like example, in the name example I'll just create. Okay, so I'll just go and use this database which I have created, example. Okay, so now I'll create a table. Okay, so I'll go to create a table in the name of customers. Okay, so just we'll try to, without this table, I don't want to confuse you with MySQL. You don't have to worry about it. Here we are not going to use it. So I'll just go and click this option to run this. Okay, so now it's created, and if I refresh this, you can see we have something known as example. A database is created. You can go and create like tables. You can add details, and these things are now stored in our RDS. Okay, whatever you are doing here is now stored here. So one thing I can like verify is, what I can do is I'll just go and exit this. Okay, I'll just go and open MySQL workbench again. Okay, so now what I'm going to do, so before going into this, let me just create a new connection and try to check whether it is updated or not. Okay, we have our example here. So this will take me to my home page, db2. I'll pass the same link. Okay, and the name is admin, and password I have it in the store and vault. You can change it. Okay, you have to enter what is the password. So that's why it went automatically in the first time. I already have the same password it is. Okay, you can go and test the connection. It's made, and you can click OK. And now it should take you inside, and whatever connection you made, it is now linked through that RDS. Okay, so you can see that example, the database we have created is there. Now you can use SQL commands to work on it. So this is what about RDS. Next, okay, if you like, once you are completed, again, once if you are done with it, it's better to remove once you haven't used it. Okay, and there are connections and it's running, and let me just make it delete it. I don't want it to keep on running. You don't want to take any copy of it. I acknowledge and delete me. Delete. Okay, it will take some time to delete. In the meantime, we'll go and see the next thing. Okay, next we are going to see about NoSQL, so which is like semi-structured data. So what we are going to see is, we are going to see something known as Amazon DynamoDB, which is a NoSQL database for unstructured data. Okay, so it's a fully managed serverless key value NoSQL database, where DynamoDB is primarily a key value store, in the sense that data model consists of key value pairs in schema-less. Okay, there will be no format like table, so they may like they are semi-structured. That's the name. Okay, there may not be any schema, or they won't be in any definite thing. And they also offers both the scalability, atomicity, durability, and availability. Okay, they provide everything, and we'll just go hands-on with it. So what I can do is, I can go and search for DynamoDB. Okay, I'll just open it. Okay, so first what you have to do is, if you want to create a DynamoDB, which is NoSQL database, you can go and click a create table. So you have to give a name for it. So I'll just give a name something like customers. Okay, the partition key I want is the customer ID. Okay, and that's it. I think we can go and click create table. I'll just show you how to store a NoSQL database here. So it will take few seconds to complete. It will be completed. Yeah, it's done. Now what you can do is, you can go and click this and go into actions. Okay, one thing before that, we'll just go into it. Okay, so here you have this table where we are going to use actions to create an item. Okay, so this is what the key value pair we are going to do. Okay, so here the customer ID is the partition I'm having. So I'll just give it like 1. So this is for customer 1, where I'll be adding new attribute. Okay, you can click new attribute and go with like whatever you want. I'll go with string. So in this customer ID 1, I have a key, I have a value. So in this key, I'll give like first name. Okay, I'll give like Virat. And what I can do, I can add another attribute, string, and what I'll do is like second name, I'll give it as like, let me select it, Kohli. Okay, I want to add another attribute, it is also a string, so I'll just go with city, I'll just give it like Delhi. Okay, and I'll add another thing, for example, it's also a string, country, and this is India. Okay, I'll just create an item. So this is now will be created. You can see these are the things we have. It's like a table, but what you can do is you can go and click this create item. Now the partition ID, I'll just give it as 2. Okay, I can create a new string. Okay, so here for example, if my customer don't have a first name, like second name, he just have one name. Okay, like for example, he has something name like Shiva. Okay, and what I can do is he don't have second name, I don't want to add it, I'll just add a string. I don't know his like which city he belongs to, so I'll just give it as country. So he's an Indian, I know it, I'll just give India. Okay, and what I can do, I just create an item. So this is semi-structured. You see those things which are not available will be empty. If you give some other feature, it is also going to be add as key value pair. So this is how you can work with NoSQL Dynamo database. Okay, so if you are done with it, you can go and check for the tables and you can delete it if you don't want it. Okay, this is how you can store NoSQL data in key value format in DynamoDB from Amazon Web Services. So fast and flexible NoSQL database service for any scale. And finally, going into the unstructured data. So this unstructured data, we have many things, right? For example, videos, photos, or dataset files, which you are going to explore in the next class. Starting with machine learning, data is important. And what you are going to do, like if you are going for block storage, you can go with Elastic Block Store, as we saw earlier. With file storage, you can go with Elastic File Store. But our primary focus is now on object storage, which is Amazon S3, because we are going to use it for other storage purpose. Okay, we have Elastic Block Store, Elastic File Store, Amazon S3. Okay, you can store it. It's something known as bucket. So it's like creating something like a folder or a bucket, so where you can store, give a name for it, and store separate things. Clear? And Amazon S3 is an object storage service that offer industry leading scalability, data availability, security, and performance. So store and protect any amount of data for a range of use. Okay, so you can use it for many things. You can have backup, you can use it for machine learning, analytics, and so. So Amazon S3 is designed for this 11 nines of durability and store data of millions of customers all around the world. And there are many types of S3 are available. If you go for standard, and you have these options, and something known as Glacier and all are there. Okay, we'll be just using this S3 standards for our machine learning purpose. So these things, they have different like versions. And when you go for S3 Glacier, so what it is doing is, so you can have a archive of data which is not that much important. If you want to store it, those will cost very less. You can compare the cost, it is given below. So those things you can use it for storage, like archive things, and they have their like front and back, they'll go and come, so some things may lost. Okay, and here it is very important, it will be very standard with S3. Okay, so what you can do is, we'll be using S3 most of the time. So what you can do is, we can go and click this S3. We'll just explore a little bit about it. S3. Okay, scalable storage in the cloud, simple storage service, Amazon S3. I have all these buckets. So if you want to create a bucket, okay, just like a separate place where you can have different files, I'll just go and create a bucket. So you can give a bucket name. This should be like unique. Okay, so my first AWS bucket. So we'll verify whether it is available. Yeah, it seems like it's available, and that region. Okay, you don't want to access any of this. We'll talk about bucket versioning later of that part, not now. it's somewhat high concept. And we can go with create bucket. Okay, yeah, this name is already exists. So 1, 2, 3, something like that. That also exists. Pantechelearning bucket S3. I think this will be available. I'll create a bucket. So this should be unique globally, okay? And you can search and see the Pantechelearning bucket is available now. So this is like storage. You can just upload things and use it. Okay, as we saw earlier. So once you go and click upload, so it will ask like which files or folder you want to add. Like for example, if I want to add file, okay, I'll just go and search this, click this data set. So if I want this car data set, it's a CSV file. We are going to discuss about what is a CSV file, how this data set will be in next class in machine learning. Okay, and what you can do is once you are done, like you can, this is a path, you can copy it. It's like somewhere else, if you want to use this data set, you can use this path to call that S3. You can go and click this upload. So this will like uploaded and this file is succeeded. Now like whenever you want, like in whatever service in Amazon, if you want this car data, you can use this bucket known as Pantechelearning S3. Like that name, you can use it. Okay. So that's what with bucket is. So we will be using bucket a lot of time. So it's very simple actually. It's an object storage where you can store videos, photos, or these kind of files. Okay, any format you can store it. And you can convert this masterclass into 1 month certified internship on machine learning operations with AWS. On joining the internship, you will be getting all these benefits such as 30 days of live sessions, 90 days of access to all the records, source codes and project files downloadables, 30 downloadable PPTs, 5 mentor live in mastermind session in Zoom where you can directly interact with the mentor and clarify all your doubts, internship confirmation letter and then internship certification. To avail these benefits, you can join the internship at discounted fee at $799 and the registration link is posted in chat box. You can join as an internship user by registering there and you can get all these benefits. You will be getting a 30 days agenda, a content for 30 days along with all the downloadables and PPTs and these project file downloadables. That's it guys. So what we'll be doing is in next class, we are just directly going to jump into machine learning. We want to see about the introduction of it and then starting with AWS Sagemaker. Okay, we'll just cover that in